This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to today's discussion. We're diving into the exciting world of educational simulations, specifically a fascinating resource called the Roller Coaster Simulator. It's an interactive tool designed to teach physics concepts. What initially drew you to this particular simulation?
The ingenious use of a familiar, engaging context, the roller coaster, to illustrate complex physics principles. It's a clever way to make learning more accessible and fun.
Absolutely. It's not just fun, though, is it? The simulation offers a lot more than just a visual ride.
Precisely. It's a powerful tool for understanding energy transformations, work, and power.
And it's all done through an interactive interface. Let's explore that. The simulator allows users to create their own custom tracks. How does this feature enhance the learning experience?
It moves beyond passive observation. By designing their own tracks, students actively engage with the physics, testing hypotheses, and seeing the direct consequences of their design choices. It's a powerful way to foster inquiry-based learning.
And the adjustable parameters like initial velocity, gravity, and mass, what insights do those provide?
They allow for controlled experimentation. Students can isolate variables, observe their effects, and build a deeper understanding of cause and effect within the system. For example, changing gravity lets them explore how the roller coaster would behave on the moon versus Earth.
That's a great point. It's like the virtual physics lab. The simulator also includes preset track configurations. What's the pedagogical value of these pre-designed scenarios?
They provide structured learning experiences. Beginners can start with simpler tracks, gradually progressing to more complex designs as their understanding grows. The preset loop or circular loop options, for instance, immediately introduce the concept of minimum height requirements for a successful loop.
So it caters to different learning styles and levels. What about the stated learning goals? What are the key concepts the simulator aims to teach?
Primarily the conversion between potential and kinetic energy, the principle of energy conservation in an idealized frictionless system, and the role of gravity in influencing motion. It also subtly introduces concepts related to forces and momentum.
It's a multifaceted learning tool. The simulation is built using JavaScript and HTML5. Why is this significant?
It ensures broad accessibility. The HTML5 format means it runs on most modern web browsers without needing plugins, making it readily available to students regardless of their device or operating system.
And the embeddability feature, how does that benefit educators?
It allows seamless integration into online learning platforms, digital textbooks, or even individual lesson plans. This makes it a highly versatile tool for educators.
It's a very flexible resource. The inclusion of a YouTube video showing a paper roller coaster is an interesting choice. What's the purpose of this supplementary material?
It provides a tangible, real-world connection. It bridges the gap between the virtual simulation and a physical manifestation of the same principles, reinforcing the concepts in a different context.
It helps ground the abstract concepts in reality. The simulator is explicitly identified as an open educational resource, OER. What are the implications of this designation?
It means it's freely available for use, adaptation, and sharing. This significantly reduces barriers to access and allows educators to customize the resource to suit their specific needs. It promotes collaboration and innovation within the educational community.
It's a powerful model for sharing educational resources. Looking ahead, what potential improvements or expansions could further enhance the simulator's effectiveness?
Incorporating more realistic elements, such as friction and air resistance, could provide a more nuanced understanding of energy loss. Adding features to allow students to analyze data directly within the simulation would also be beneficial.
And what about its potential applications beyond the classroom?
It could be adapted for use in engineering or design contexts, allowing students to explore the design constraints and trade-offs involved in creating real-world roller coasters.
The possibilities are quite extensive. The For Teachers section provides specific instructions. Why is this crucial for effective implementation?
It ensures that educators have the necessary support to effectively integrate the simulator into their teaching. Clear instructions on using the combo boxes and adjustable slides are essential for maximizing the learning potential of the resource.
It's a key element in ensuring successful adoption. The expensive list of other simulations on the platform is noteworthy. What does this suggest about the overall project?
It demonstrates a commitment to providing a comprehensive suite of interactive learning tools. The breadth of topics covered highlights a holistic approach to science and mathematics education.
It's a valuable resource for educators seeking diverse interactive learning materials. The accompanying study guide includes a quiz and essay questions. How do these assessment tools contribute to the learning process?
They provide opportunities for students to self-assess their understanding and apply their knowledge. The essay questions, in particular, encourage deeper reflection and critical thinking.
It's a well-rounded approach to assessment. The inclusion of a glossary and sample learning goals further enhances the resource's usability. How do these elements contribute to its overall effectiveness?
The glossary ensures clarity and understanding of key terms, while the sample learning goals provide a framework for aligning the simulation with specific curriculum objectives. These elements make the resource more accessible and user-friendly.
It's a very well-structured and comprehensive resource. The FAQ section addresses common questions about the simulator. What is the value of providing this readily available information?
It proactively addresses potential user concerns and provides quick answers to frequently asked questions, improving the user experience and making the resource more accessible and user-friendly.
It's a thoughtful addition to the resource. So in summary, the roller coaster simulator is more than just a fun interactive. It's a powerful educational tool.
It effectively leverages the engaging nature of roller coasters to teach complex physics concepts in an interactive and accessible way. Its open nature and extensive support materials make it a valuable resource for educators and students alike.
And its adaptability makes it a versatile tool for various learning environments.
Absolutely. The potential for further development and expansion is also significant.
That was a great discussion. Thank you for your insights.